Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This video is part 4 for recurrent neural networks and long short-term memory networks. So let us see the model accuracy. Okay, so this is the chart: training accuracy, validation accuracy. Blue line for training accuracy, validation accuracy is this orange line. Training accuracy steadily increases over the epoch. So training accuracy steadily increases over the epochs. This suggests that the model is learning and improving its performance on the training data. So learning and improving its performance on the training data. By the fifth epoch, the training accuracy reaches 94%. You can see here. So by the fifth epoch, training accuracy reaches 94%. Validation accuracy, it is going down like this. So let's see in technical terms. The validation accuracy starts lower than the training accuracy around 88% and slightly decreases over the epochs. So it is decreasing, and this is 88%. By the end of fifth epoch, the validation accuracy is about 86%, as you can see here, 86%, which is lower than where it started. So it is getting lower. So this is validation accuracy. So as you can see here, accuracy is 94%. This is actually decreasing validation accuracy. So interpretation is overfitting. The graph suggests that the model is overfitting. This is because the training accuracy keeps increasing. Training accuracy keeps increasing while the validation accuracy declines. Validation accuracy declines. In overfitting, the model performs well on the training data but fails to generalize to unseen data. So it can perform good with the training data, but when it sees the new data, then the accuracy is not as the accuracy we need is, we are not getting that kind of accuracy. So this is what this means. So what you can do to fix it: regularization techniques like dropout, early stopping or L2 regularization. So I told you these kind of techniques in some techniques in the previous session, but not these techniques. So you can try out these things also. So there are many techniques available to fix this. So increasing the size of the validation set or using techniques like cross validation might give more robust validation accuracy. So there might be think that validation accuracy is not coming right here. So you can try more techniques like cross validation to check if the validation accuracy is giving right. Simplifying the model architecture. So how you can do it: reducing layers or parameters also can help overfitting. So these are some possible things that can be used to fix this problem, but I have not fixed those things in this project because I just want to show you the basics, how to read these things and how these charts work. So here we have loss chart. So this is the train loss, it is going down, training loss. Validation loss is going up. So this is the simple way you can look at the chart. So what are the technical terms? So the training loss decreases. Training loss, blue line, decreases significantly over the epochs, while which indicates that the model is becoming better at minimizing errors on the training data. And by the end of the fifth epoch, the training loss is very low, close to 0.10. So you can see here. So this is how in technical terms you will say things. And for validation loss, the validation loss on the other hand starts around 0.30 here and increases over the epochs. By the end fifth epoch reaches around 0.4, which is notably higher than where it started. So you can see I have mentioned everything here, and the let's see the interpretation. So overfitting, again the same thing, similar to accuracy plot. This loss graph suggests overfitting. The training loss decreases steadily, meaning the model fits the training data well, but the validation loss increases, showing that the model is not generalizing well to unseen validation data. Again, it's see increasing, loss is increasing. This means it will not perform good on the new data. Diverging loss curves. Ideally, both the training and validation loss should decrease together. However, in this case, while the training loss is decreasing, the validation loss is increasing, indicating that the model is memorizing the training data rather than learning generalized patterns. So you can see the problem here. One is going down, one is going up. So what are the actions that you can take? Implementing early stopping could be beneficial as the validation loss starts increasing early in the training process. Techniques such as dropout, again same thing, reducing model complexity, number of layers, again the same thing. Also you can try those things. And I told you this is how it will show automatically the layers we have used. So as you know, we have used these 3 layers in the sequential, and these are the 5 epochs details it is showing. I have included the epoch details here, so I will tell details for 1 or 2 epoch, then you will understand how to read this. Okay, so let's see this thing, epoch results. So epoch 1, epoch 2, let's see epoch 1. So this is what we have: 500 by 500, 46 second, 39 ms per step, accuracy loss, validation accuracy, validation loss. So how to read this? Training accuracy is 77.39%. This is 77.39%. As you can see, 7739 to 77.39%. Training loss is 0.4422. Then validation accuracy is 87.89, and val loss is 0.2982. So the model starts with relatively high validation accuracy, suggesting a good starting point. This is what this means. Epoch 2, similarly you can read these things from here: accuracy loss, validation accuracy, validation loss. So this is how to read this. I have mentioned all 5 epochs in the article. So what is the final thing is the test result. So test accuracy is 85.58% and test loss is 0.3835. So the test accuracy of 85.58% is close to the final validation accuracy, which suggests that the model is performing consistently between validation and test set. However, the model might not generalize well as it could due to overfitting. So model is performing but not up to the mark. So this is the thing, this is how to read this. And then of course the classification report. Let's see the classification report, how it looks like. So in the previous sessions I have shown you this is the classification report and how to read this. So you will have these columns: precision, recall, F1 score and support. Okay, so in the form of 0 and 1 you will see these 2 rows here, and out of all predicted positives, how many were actually correct. So this is precision. Out of all predictive positives, how many were actually correct. And recall, out of all actual positives, how many did the model correctly identify. This is recall. F1 score, the harmonic mean of precision and recall, balancing the two. And support, the number of instances of each class in the test result. So this is the thing. And class 0 is negative sentiment, positive sentiment is class 1, The classification report provides detailed performance metrics for each class, as you can see, for each class. Precision 0.86, what it means. Okay, so this one, what it means is, out of all the predictions the model made as negative, 86% of them were actually negative, correctly or were correct. Class 1 precision 0.86 means out of all predictions made as positive, 86% were correct, that is truly positive. And precision is important when the cost of the false positive is high. In this case, precision reflects how many of the reviews predicted as negative or positive were actually negative or positive. So precision, with the one word you will understand the precision, what it is. Recall 0.85 means out of all the actual negative reviews in the test set, the model correctly identified 85% of them, and similar cases with the positive, but 85% of them. And recall is important when the cost of false negative are high. There are recall shows how well the model identifies all instances of positive or negative sentiment in the dataset. So this is what recall is. And F1 score, model is performing well in terms of both precision and recall. So these are so F1 score is connected with precision and recall. And support, number of actual occurrence of each class in the test set, so how many times it came. So you can see the support here. So what it means, there are 4961 negative reviews in the test set. There are 5039 positive reviews in the test set. The support values are nearly balanced, which makes the overall accuracy and performance metrics easier to interpret without needing specific weighting for one class over the other. So in simple words, you can just look at the support. So it refers to the actual occurrence of each class in the test set, and there are 4961 negative reviews and 5039 positive reviews in the test set. This is what it means in support. And accuracy, with one word you will understand what accuracy is. And macro average and weighted average, two things are mentioned here. If you see macro average and weighted average, what they means is, macro average of precision, recall and F1 score, these averages are calculated by taking the mean of the score for each class without weighing by the number of the instance. Okay, so the main thing written here is 0.86 for all three things is the macro and weighted average. This is the thing here. And average, you understand what it means. These averages are macro average are calculated by taking the mean of the scores for each class without weighing the number of instances in each class. And this one, what weighted average is, this average weighted by the number of instances in each class, providing a summary that reflects the class distribution. So when you are working with summary, then weighted average, and when you are calculating the mean of the score for each class without weighing the number of instances in each class, then the macro average. So this is how it looks like, and both are 10,000 here. So what's the summary? So the model performs equally well for both positive and negative sentiment classification. The dataset seems fairly balanced, making the macro and weighted average equivalent, and the good generalization, the F1 score of, suggests that the model is performing well in predicting both positive and negative sentiment with a good balance between precision and recall. This video marks the completion of recurrent neural networks and long short-term memory networks. I will see you in next session. Have a nice day.